Okay, welcome everyone. This is an introductory class to data analytics. So we will be starting first with an overview of statistics before moving to probability and then inferential. So the we're starting with statistics because basically in data analytics we are doing two different things. So the first step when we're faced with data, we need to understand what this data is telling us first. What is it describing? What does it? How can I make conclusions just from looking at the data and looking at how it's behaving without making any generalization, without making any assumptions about the future or about the general population. So the first objective is just for us to understand what the data that we have is telling us as an information. So transforming the data into an information that we can use. So without making any assumptions about the future. The next step would be, so once we master that, then we can move to predictive, making some predictions, making some assumptions, making hypotheses, and trying to validate our assumptions and our hypotheses with the inferential statistics, which we will cover in the future. So my name is Hala OUARRAK. I have a PhD in applied mathematics and automatic control. I am also an engineer in industrial and logistics engineering. I have worked mostly in project management, industrial engineering, ERP implementation projects, and whatnot. And it was usually heavy on data management. I also taught courses in universities, Toronto Metropolitan University, Northeastern University, and whatnot. And it was, and then I decided to sell my own course because I realized that there was a disconnect between what universities are offering, which is usually too short of a time to cover everything, and what online courses like videos that are usually available on like Udemy, Coursera, and whatnot that are very detailed, but you don't have the instructor led experience. So you can't really ask the questions. You don't, and they tend to uh, uh, skip through themes and whatnot very quickly. So the purpose here is for you to understand every concept as if you're in a university, and to make you participate as well in the class. So I expect participation, and completing the assignments. So let's start with some broad definitions. But before we can start on that, I want to go around the class and ask, so what is statistics or data analysis for you? So who wants to be the first? And I'm not looking for a textbook definition. I'm talking about your own definition of the word data analysis or statistics. When you hear those words, either from your work experience, from your studies, what does that tell you?
If I may.
Yeah. Yes, Chitan?
So data analysis, as to what my understanding is, like just doing a deeper um, study about the data and trying to understand if there are any patterns or any patterns for one, and then just trying to find more trends within the data, or if there's any, like there could be a lot of biases you could see, or you could not see any biases. You could really see a very normal distribution with your which is a very rare case, I would say. But
Yeah.
patterns, and then patterns and trends is one, and then you can also look for any biases. That's second. And um, what else?
Okay. Yeah. You brought very important keywords here. I will mention each one of those, but thank you. That's definitely part of statistics, not of this chapter, but part of future chapters. But thank you. These are very important keywords. Yes, Leila. Thank you, Shijan.
I
Yeah,
will try
Leila.
to. Yes. Can you hear me?
Yes, yes, we can hear
So,
you.
hi everyone. So I think for me it's a set of tool mat based on mathematics and
Okay.
reasoning used for analytics. So to analyze the data, understand a certain situation, and then also enable us to do these assumptions, maybe as you said, and maybe predict and
Okay, so
model,
assumption, the
modeling,
oh, I like,
maybe.
yeah, modeling. Yeah, I like that. My handwriting is not great, so yeah, forgive that. Yeah, so verifying assumptions, modeling. Anything else for you?
Um, yeah, I think it's a tool to analyze raw data,
Yeah. Okay.
which
Raw
may
data.
be not
Mhm.
clear, maybe.
Good. Good. I like that. Thank you. Yeah, I'm getting a very good keywords. Thank you. I will put everything into perspective once I hear everyone's feedback. Who's next? I
Can I
can't
add?
see the list. I'm sorry.
Can I add to this?
Yes, yes, Shalini. Yeah.
Yeah, so I think data analytics is like for a large set of data because
Mhm.
when we have a very small scale, more small scale data, it is very easy for us to represent it using basic Excel tools like pie chart or a bar plot or something. But when we have a whole set of data, like more than 200 or 300 observations and stuff. So if we
Mhm.
want to visualize that in a meaningful way and we want to um, tell it in a way it is interpretable for an audience, like for a large group,
Right.
then we can
Right.
make the best use of these tools, is what my
Yeah,
understanding
absolutely.
is. Yeah.
Absolutely, that's definitely one of the objectives, and the term is very large data sets. I'm sorry, yes, I should very large data sets. So that's a very known term in statistics. That's ahead of the curve here, so we may not be able to cover that uh, in this first course, but it's definitely we will definitely set the ground for it. So that would be the next level. Thank you, Shalini. That's definitely a very important objective. And part of the reason why I want what I want from this course is for you to gain a skill of, how to understand the process regardless of the machine, regardless of, the automation process, so that you can apply it to scale it for very large data, which is the current demand, basically. Uh, who's next? Thank you, Shalini. Any other volunteers?
I can add some information. I
Yes,
was
Ritik.
working in the
Hi.
data analysis field only. Uh, we used to analyze data in order to build strategies, in order to find solutions to a problem.
Mhm.
You know, using pivot charts and stuff. We used to analyze the data and try 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 to extract more information so that we can uh, idealize solutions in order to provide
Right.
those solutions to our customers. So
Mhm.
I was looking at it through that perspective, working in an organization. Yeah.
Yeah, yeah, definitely. Yeah, I mean, that's why, strategy analysts like that's a very well-paid job because in strategy you have to take into account not just the quantitative data that you're looking at, but also other types of variables that you need to put into an equation to tell you which option makes more sense for the organization in the long term. So you want to have a vision not just for the current year, but also, in the next 5 years what would that look like and how would that impact the organization? Definitely,
Right.
that's
Yeah.
a very important usage of it. Thank you, Shritik. And okay, I think there's only one left. Sandy, are you there?
Yeah, hi.
Hi,
For
Sandy.
me, data analysis is something a raw data to
Mm-hmm.
be keep it in an organized way so that we can find the
Okay.
pattern and the trends and we can make an insights and from that. From there, we can able to when it put in our discussions or any other future use, any improvement, anything to be
Right.
or put it into a discussion or dashboard or something.
Yeah, absolutely. So visualization. So
Yeah,
yes. And this is
visualization.
something, yeah, this is something that we will be starting with, is how to visualize the raw data. Like before understanding what's how the data is behaving, we need to understand how the data is actually, like, before we can figure out, does it need cleaning, does it need so specific organizing and whatnot. We can retrieve information from it first through visualization that can help us, like, we can draw the scatter plot that can give us an idea of how connected the points are, where they all lay. I mean, we can see that visually before we can go through our analysis. So definitely, thank you all for participating. Definitely, we will be talking about patterns and trends and how to avoid the observation bias, because I mean, even assuming, like, if we assume, and the bias is very important here, even if we assume that we can reach every individual of a population. So we will define all these terms. So these are our statistics terms. So let's take students in Canada, all students in Canada. So that's a huge population. You would agree. So every student, and no matter what the university. Uh, uh, so if we take this population, it would be impossible to reach every student to get their feedback on stress during exam period, right? If you want to, conduct a research. So even assuming that we could, like, hypothetically speaking, in an ideal world, let's assume that we could get every single student to answer our survey and get the information about, their anxiety level during the period of exams. There will still be bias. Why is that? Why do you think that would that be? Even if we assume that we have access to every single person and they can answer the survey for us, how can a bias occur despite the fact that we were able to reach all? Any ideas?
Probably because not everybody will understand the questionnaire or what is asked the same way. So everybody might have his own narrative.
Yes, that's true. First understanding what is asked, so they may not, they may misunderstand, or there could be other variables happening. Because let's face it, if I come to you and I ask you about your stress level, you may be in a situation that is unique, that doesn't happen all the time, and you may tell me, oh, I'm very stressed out, but it could be just a one-time thing, when usually you're a very relaxed person, and vice versa, right? So the bias of observation can happen in different ways, in multiple ways. And that's why there's a whole section about the design of experiment in health science, that allows the researchers to control the environment for the subject, that are for the individuals that are studied, to reduce the observation bias. So that's a whole other sector. Again, that's why statistics is such an ocean of concepts. I will allude to the the different applications, but we won't be able to cover it on this course, but at least not on this first course. But in terms of trends and patterns, that's definitely something that we will be covering, because that's an easy thing to do. Once we are able to correctly describe, visualize, describe the raw data that we have, and organize it in a meaningful way, then we can see the patterns and trends. It would be easy to do that. We would also be able to have a model for our data to make forecasting decisions, to see what the next year would look like, what the next 5 years would look like. And we will be able to make assumptions about the future and verify whether this assumption is true or false through hypothesis testing. So that's also something that we will be covering in the future. Any questions before we can start? So this is a good discussion. I'm very happy with it. Any questions relating to what we will be covering in the course before starting?